Shri Sukdev Das ji. He is the director of Bhaktivedanta Institute, Radhakund, UP. So the title is Photon Encounter Consciousness, Consciousness Visual Perception in Neural Spatiotemporal Dynamics of the Brain and its Interpretation from Vedic Perspective. Shri Sukdev Das is serving as the director of Bhaktivedanta Institute, Radhakund, UP. He obtained his undergraduate degree in life sciences from Manipur University. Inspired by Dr. T.D. Singh, he dedicated himself in serving the Bhaktivedanta Institute at various levels. He has been instrumental in development of the Bhaktivedanta Institute at Radhakund, UP. In addition, he obtained his MSc in Life Sciences from Karnataka State Open University in the year 2016. His interests of study include the interactions of body and mind, study of consciousness from both scientific and Vedantic temperaments.
First of all, I would like to thank all the dignitaries and all the scientists, those who are here. And this talk is especially for the students, those who are aspiring for research work. So I don't have my own research work yet, and I'm aspiring for that. That's why, and earlier speakers are all like my mentors. So if there is any flaws or anything, please just give more commentaries and for future justifications. And especially these are for my student folks, those who are like, aspiring for that. So photon encounter consciousness. This is a very interesting field that I'm aspiring for my research work. And consciousness visual perception in neural spatial temporal dynamics of the brains. So in this Einstein space-time, whatever we have is in the external world. But now I'm going to give a kind of reverse presentation from inner views, how we see things in the, so that will be interpreted from the Vedantic perspective also. This is my mentor. This is the quotes, and from this inspiration comes to me. Origin of life and universe is mysterious. So yesterday, today, everyone is talking about certain mysterious. And without knowing what is consciousness and its origin and the origin of the universe, how can we come to certain conclusions without knowing the actual root cause of these origins? So let us explore. And according to Dr. T.D. Singh, this is known to everyone, those who are in the research works and those who have their own think fields, that there are two categories of consciousness: universal consciousness and individual consciousness. And if individual consciousness is not known, it will be difficult to understand the nature of universal consciousness. So today's topic is more related to individual consciousness. Consciousness is the living energy and the fundamental quality of light particles. What it means, let's go. Okay. This is a journal I recently followed for many of these publications. This is from the Big Think. It's a very recently accolade website where they publish certain things where many other science journals, they did in a very exaggerated manner. But this one spoke something more to the reality. So far we have known to our perceptions or our realizations, but not much exaggerating. So for example, the scientific discoveries so far about the space is about, say, 13.8 billion years old after the Big Bang that was happened. But so far, only 300,000 years back, after the big bangs, that's how we have been come to a certain level of understanding. It's like a fog. When we look into horizon, when we stand near the beach and look into the horizon, like an example, this is about 300 kilometers. Beyond that, we don't see anything. So then we need other extended senses like instruments. The instruments, sometimes they only focus on certain areas and we may not be able to see in a very wide range or in a very precise manners also. So machine has some advantage, but it is not always complete or perfect. So our actual understanding so far is only 300,000 years after Big Bang. Okay. So now I come to the point. So after the Big Bang, there's the recombinations happens in time. Time is according to this Einstein's space-time. Time is one linear, but not. I'm not talking in our linear and a circular time frame in the Kala Chakra where I don't talk about it. So there is a before recombinations and after recombinations, this electromagnetic spectrums of our worlds is starting from the high frequency gamma to the low frequency radio waves. Then in a higher range of waves, the radio waves are the highest one, but the gamma rays on the left are the smallest in the nanometer scale. But out of that, this WebGear, this is the only human perceptible range of electromagnetic spectrums. This is very small fractions, 370 nanometer on the left to around say 740 say nanometer. This is the only perceptible range of spectrums in our human eyes because we are talking about the human. And other animals, they don't see certain ruminescent animals, they don't see color because they don't have certain pigments in our eyes. But do we really see color? That will come in the next. Light can behave as both particles and wave. I don't need to speak much. That's how we know. And then wave collapse, then become particles, and particles, when it becomes particle, then it is the moment that how our retina able to perceive and transduct it into electrochemical transmitters. So I don't need to speak much more about it. And how photons are being transmitted, emitted. This is one of the examples, Bohr modern from the higher energy level. When it cools down to coming to the original position, it releases certain energy that release say 1 photons. This is one example. There are many other examples I have given, source of photons, radiations and emissions coming from thermal radiation, nuclear radiation, chemical reactions, cosmic phenomena, radioactivities, etc. These are the certain other natures of these photons being released. But all the photons have no mass, but it has energy and momentums. Okay, this is very interesting. And I want to see this, this superposition of the case in our visual cortex in the brain instead of watching it outside. So Schrodinger's thought process was done in a say external space-time, but I want to do it in a mental level as well as from the other medical say levels. Let's see. This is a Schrodinger's case, but there are many other options. Nowadays, we have this, this spy cams. We can put one spy cam inside the box, and then we can also observe here whether the cat is still alive or not. After that, Geiger counter that activate the biles and then break the glass. Now we can just, instead of opening the box, we can also imagine in another way. So it's like, Schrodinger's is watching just like, and alive instead of opening the box. So this is a very nice quote from our Henry staff. I met him. He was visiting professor to our Bhaktivedanta Institute in Mumbai when Guru Maharaj was there. And he's a theoretical physicist, and he was very much interested in our Vedantic perspective of consciousness. So he says, the conscious thoughts of a human observer ought to be casually connected, mostly directly and immediately to what is happening in his brain, not to what is happening out at some measuring device. This is regarding the quantum superposition of the kids, dead and alive, half dead, half alive, is this paradox. So this is actually a thought process or thought experiment. So that doesn't happen in a reality, but in a, say, quantum level, it's happening simultaneously. This is being proven. But while in observation, we only found only one, either wave or particles. Next. Okay. Our human eyes is very, very complicated and sophisticated and also very mysterious. For example, when you look into outer, say, space-time, we see shape of a particular object where we focus. Its dimension, deep, length, breadth, and say height of the order dimension or shape. Then color, orientations, up or down, and the depth from the observers. How we perceive all such things. And the number one, regarding these orientations, the pinhole camera is a very old theory that we have been taught in the school or high school, college physics about pinhole camera that is being applied in the eye. But it is really not exactly because the orientation up and down and the photon waves carries electrical waves up and the magnetic wave and down. It has a polarizations of two waves, together, and it's being filtered, and we see only one polarized wave. So that's why I have intention to revisit to see the orientation, but in the scientific presentations and the journals and other research work, they said visual orientation is corrected by visual processing. I want to revisit this also. Actually, here, this slide is not so very clear. This is, I made it the cat dead and alive, just for the representation only. And this is being the photon reflections from the cats coming here, and but this is not the actual way. From this focal length, then coming to the fovea, where the concentrations of rods and cones are very high, but especially cones, which is responsible for the color perceptions. And the cone itself has, again, 3 different cells. So in the fovea is here. There's the highest concentrations of these cone cells are being there, but it's supposed to be, the focal length, and then the focal point must come here. So the way how we studied in, this pinhole camera and inverse pictures. So this is really not. So, so this is how I am just, for the sake of presentation, it is here. This is how it is, light's coming. And the next slide, let's see a little bit in observations. Retina is in the back of our eyeball. And there are many other mysterious things still, for me it's a mysterious, but for doctor, I don't know. See, there are 11 layers of cells, and this is only half a millimeter thick. This is the retina. And it has 9 different cells. The first one is this is the retinal ganglion cell is responsible for the dim visions. It doesn't identify any color or anything, but it is sensitive to light. When it is turn off the light in the room, someone who is having a retinal problem, but this is the responsible for the perceptions of light. And then it has amacrine cells, then bipolar cells, then a horizontal cells, then the retinal cells. And the retinal cells are again cones and rods are responsible for the low intensity lights. That's say 300 nanometer to 445 nanometer range. That's where the in the nighttime we need more lights, but other cones are not able to be activated. Only the rod cells are being able to be activated. That's why in the nighttime we see only black and white most of the time. And then see, the light is coming in this way, an example, then it is coming here. These are the different layers of the retinal cells. But the mysterious things is that why the first light, the photons comes here, and why this photoreceptor cells, why it is at the back of the retina is again wondering. Why it does not appear here in the front to receive the first rays of light? Why this is happening in the evolutions of the nature? It has a purpose. Suppose when we are being exposed to some bright lights in the natural sunlight, and it has UV lights and also infrareds, but these are all filtered. But actually it is enters in our eyes. But if these rod and cones are in the front, then it will be definitely damaged, right, sir? That's why see how the nature has put these photoreceptors, retinas are in the back of the eye. This is a wonder, again, a kind of something intelligence behind this also. Okay, these are a little bit of the these rods and 3 different cones. These are responsible for color of light that we saw, and these are the different range of these lights seeing in a nano scale level. For example, here, beautiful yellow color you see, but this is not yellow according to this our neuronal network perceptions, because it emits only the photons coming from the lights, and that reflected. It has about say 445 to 600 nanometers of wavelengths, and that enters into your eyes. That activates the frequencies and the wavelength that activates your retinal, this yellow one. Then that's how you see it. In the color blind people, they don't see color because there is a faults in their these retinal cells. So it's a little mysterious from our day-to-day classical life. But when we look into our internal life, how it's happening is a very wonderful, mysterious, and also very intriguing. So from this onward, our visual perception is completely different. What we see, you and I, all this is not here outside. It is in the brain, in our cortex. Okay, this is the area where concentrations of this cones in the fovea is much higher than the rest, and this is given here. This is the fovea area, and this spike is the area where the fovea, the color perception is much higher. and this is on the nasal side of the brain, and this is on the temple sides of the brains. And so these are the spike of the cones. Rods. Rods are responsible for other perceptions when we look into certain object and focus, and other peripherals are there. These are mostly being, I mean, on the rods in the retinal cells around the fovea and beyond, that is being reflected. Okay, this is a very highly advanced subject, but I'm just giving a little bit short description. Sorry. Let's take it this as one of the retinal cells. This, in this case, is the rod cells, and this is nucleus, and there's other, it has a sequence of layers, and these are the photoreceptor molecules being, say it has a very complicated, and this is being studied in phototransductions, but for the sake of presentation here, this is the photoreceptor cells, and one photon is coming here. One of these options is one of the retinal molecules, then it accepts. Then what happened in a molecular level, this cis options molecule is in a cis levels. Cis is just like in a chemistry, we have left hand and right hands. So with the interaction of photons, single photons or certain number of photons to activate, then it changes from cis to trans. My question is, this is all happening in a vivo, in a life, in a not in a dead body, in a living person. Yesterday I had some interaction, but still I'm going to go for some more research work on this. This is what I'm interested. But in a sleeping man, if this who's sleeping in a deep sleep or in a REM state of, the 0.5 to 4 is the alpha waves of the brain. Yeah. Okay. Okay. So, so how this is going to happen in a sleeping man? It is going to be activated or not? This I want to go for. Next slide. And this is the structures of neurons in the brain and how it's working. Everyone knows. And then a different part of the brains where I'm interested is that where the visual cortex are being mostly in the occipital lobes of the backside, where B1, B2, B3, and B5, which are responsible for different perception of light. And here in the frontal cortex is for the, recognitions and analytical. I take only this part because in one recent study, I will come to the next slide. So I will not take other part of the brain because this is related to visual. This is the area where most of our visual perceptions are happen. But the conscious perceptions, that's why I put this area here in the frontal cortex. That will come next. So this is where. So first, the light being received, and this is the optic nerve, then optic tracts, then LGN, then optic tract, radiations, and B1, B2, B5 in the visual cortex in the occipital lobe. And then again, there is a dorsal streams and ventral streams, which are responsible for certain functions. Okay, conscious visual perception in the neural spatiotemporal dynamics. Okay, conscious perceptions, and one is a phenomenon perception. Phenomenon perception is something, I see something, but without analyzing. That time, it's happened in the visual cortex, in the back of the brain, but analysis, what is this and what is that? That comes to a paper. This is about the brain wave yesterday also being mentioned, and so I don't need to go for more. So this is a very recent study. I have been following few research work, and these are being coming up in the only last 3 years, 3 or 4 years, that most of our perception is that visual perception is happening only in the back of the brain. But with this 2023 review paper, in this research work, it comes to a very close understanding that conscious visual perception is happening in the frontal cortex also. So this is a review here, December 2023, something like that. And I will not go for more. And this is how they use certain mechanisms for observing how this conscious perception is happening. They use Gover gratis. But this is, from my point of view, is a very simple and infant stage of the eye movements. For example, the gradings of this, having strips of different grades, 1, 2, 3, and there are 2 holes here, a red, a green and red, and the eye movements on the left will give you, say, green if the gradings are this. But this I don't want to go for. But why I'm showing this, I want to develop a device like this, but not how to see dead and alive of that kid. So instead, we can make like, one, okay. And only say green is for, so we have to train the subject that the green is for alive and red is for the death. Then we train up like this, and then suddenly we brought this green and red together and said is both dead and alive. Then that time the brain's activation, where it is being activated, that it can be used by using either EEG or fMRI. That's what I have a little bit interest on that. So these are the different brain waves being scanned through EEG and fMRI, and they use computerized brain LS. That's how it's where they are being activated. These are just only for the sake of presentation. And then this one is what I wanted to observe. Who is watching the movie? But actually, this is not what, but I take it in the reverse way. For example, let us take this projector as inside of the eye. Then it's projecting to the screen. This is the visual cortex in the back of the occipital lobes. And the reflections coming again. Who is watching? Is the person, right? Where is the person? So it says that it is a frontal cortex is a very recent study. So this Hamrov's objective reductions, I want to go into the cellular level, but the time is now off. But I have 10 minutes for the question and answer. I might not be able to take any question because I'm not a researcher. Please allow me to take at least few minutes from these 10 minutes because still I have 10 more minutes. Okay. The 10 minutes is there for question and answer. I may not be able to take any question and answer. Okay. This orchestrated objective reductions is very interesting. And this is the word being orchestrated is like a coherence. Objective reduction is decoherence or say web collapse. This is how I understood from this Hamrov's and our Sir Roger Fenro's views on the, I'll come to the molecular level. But there are objectivities of the wave reductions, and then the consciousness arises more or less like in the physical level or empiricals in the neurons, and there are these microtubules, but this is from our Sir Anirban that I'm following right at the moment. I have interaction with him. He's from Calcutta. Is Anirban Bandyopadhyay. He's working in the National Institute of Material Science in Japan. And so I have a lot of correspondence with him, and I'm following him, and he used this state of the art, scanning tunneling microscope that comes to the point up to the, say 2 nanometer levels of focusing of the brain's neurons in the living cells. This is a very astounding recent development. And he says that when he comes to this interaction with the microtubules, and not only microtubule, this is also actin microfilament also behave like a, same thing, but more or less it's like a microchips, they're storing memories in the electric. So he says, instead of consciousness, there are certain properties it has. And it comes down to the, it has only 20 nanometers weight of this diameter of this nanotube of microtubules, but he said he can come down to 2 nanometers level. And there are many other things